Hello everyone, this is Mr. Auble. We're going to be doing a video on solving absolute value equations. I'm going to be here alone this time. We're trying to complete it at lunchtime and we just figured out how to get it actually taped, and Ms. Vaughn is back teaching a class, so I'm going to try and handle these 5 examples myself. So as we're solving these absolute value equations, they're a little bit different because we're going to be looking for possible multiple solutions here for each one of these problems. So I'm going to start with problem number 1 first, where it talks about finding the absolute value of x has a value of 6. So we have to try and find out what the value of x would be. So when you're trying to solve these problems, the first step that I'm going to do here is it's all set up ready to be solved. And the first thing I'm going to do is I'm going to remove the absolute value, but I'm going to realize that there's really 2 possible solutions. Either x will equal 6, or the opposite of x would equal 6. Now I'm going to go through and actually solve these so you get an idea of what I'm talking about, why this actually works this way. So the first one's already set up for you. Hey, x equals 6, that's the answer. X could equal 6, and that makes sense because if I put 6 back in to that particular problem, the absolute value of 6 does indeed equal 6. So that is a true solution. Now the other one we're looking at and saying, well, what does that mean? The opposite value of x equals 6. Well, I'm going to solve that for x. So I'm going to divide both sides by -1. So I get x equals -6. So let's see if that one works as well. So if I look at it and I plug back in, I check it in, I get absolute value of -6. Does that equal 6? Well, of course it does, because the absolute value of -6 is 6. So 6 equals 6. That is the solution. So the way we write our answers then is we can say x equals 6 or -6. Don't say and -6, because you can't be equal to 6 and -6 at the same time. You're either equal to 6 or you're equal to -6. Either one will work in this particular case. And that's the solution to the first problem. Now I'm going to move on to problem number 2, and 2 is a little bit trickier in a couple of ways. Inside the absolute value, there's an x plus 2, and out in front, there is a -3. And another thing that makes it tricky, actually a third way, it's set equal to -15. You think, well, wait a second, Mr. Auble, Ms. Vaughn, they told us that absolute values can never equal -15, well, can never equal negative number, and that's true. However, there's all this other junk we need to get rid of all this stuff first before we actually make our assessment of whether we can actually find a solution or not. So I'm going to treat this just like a regular equation. I'm going to divide both sides by -3. And when I do that, the left side, the -3 cancels out with the -3, and I'm left with the absolute value of x plus 2. But now it equals -15 divided by -3. That's a positive 5. So now there's actually a possible solution here. We're going to actually find them right now. So I'm going to start and do exactly what I did on the first problem, but it's a little bit trickier because now I have to do this. I have to write x plus 2 could equal 5, or the opposite of the quantity of x plus 2 could equal 5. Oh, I'm sorry, I made a mistake right here. I'm going to back up. I don't feel like redoing the whole thing, so I'm going to erase, and I'm going to put the opposite of x plus 2 equals 5. Now, you got to be careful. It's not just like in the first one when we took the opposite of just x. It's the opposite of the entire quantity. So that's why I put the parentheses around the entire left-hand side. So now if I go through and I solve this, for the left-hand problem, I'm going to subtract 2 off of both sides, and I get x equals 3. Or go to the right-hand side, my first step, I'm going to divide both sides by -1. So now I have x plus 2 equals -5. And when I subtract 2 off of both sides, I get x has a value of -7. So my 2 solutions are going to be x equals 3 or -7. And I might as well go back up and check them and make sure that I actually do have the right answers, because there's no point in us continuing if we're doing it all wrong. So if I come back up and I check in 3 for x in the first one, I have -3 times the absolute value of 3 plus 2, that's 5, and that's going to equal -15. Well, that's true because it's -3 times 5. That doesn't equal -15. When I check for the other one, I'm going to change to a different color right now so you can see a little bit better. If I substitute -7 into the problem, I get -3 times the absolute value of -7 plus 2, and that supposedly equals -15. So well, -7 plus 2 is -5, so it's -3 times the absolute value of negative 5 equals negative 15. Well, here's where you have to use what you understand about absolute value. The absolute value of negative 5 is 5. So I really have negative 3 times 5 equals negative 15, and that's a true statement. So therefore, my answers of 3 or negative 7 are correct answers. All right, now I'm going to go over to problem number 3 and see what I can do with this one. When you look at number 3, you'll notice it's quite similar to number 2 in the sense that there's a bunch of extra stuff added on, not only to inside the absolute value, but outside of the absolute value. So my first step over here is going to be to get that absolute value stuff all by itself. So before I even analyze whether I can even solve the problem, I'm going to subtract 2 off of both sides. That gives me the absolute value of x minus 4 equals 6. All right, so I look at it, I go, yep, absolute value of x minus 4, the absolute value of that stuff can equal a positive number, so I need to proceed. I need to continue solving the problem. So at this point in time, I'm going to do what I did before. Either x minus 4 is going to have a positive value, so it's going to equal 6, or it's going to be its opposite value, so I'm going to put the negative out in front of x minus 4 equaling positive 6. So remember, I'll end up taking the absolute value eventually anyway, so it's either going to be a positive or a negative. So if I do the left one first, I add 4 to both sides, and that gives me x equals 10. Let me check that and make sure that it is right. I'll do the check first instead of waiting till the very end. So I go 10 minus 4, the absolute value of that, plus 2 equals 8. 10 minus 4 is 6, so the absolute value of 6 plus 2 equals 8. Absolute value of 6 is 6 plus 2. And yes, indeed, that does equal 8. So far, so good. I've got the first half right. So now let's go to the second half, and I'm going to change colors so we can see the difference. I'll switch over to black. So now I have to get rid of that negative sign first. So I'm going to divide both sides by negative 1. So that will give me x minus 4 equals negative 6. I just divided both sides by negatives. Remember, that negative out front really means negative 1. So now I'll add 4 to both sides. And that's going to give me x has a value of negative 2. Let's see if it's right. I'm going to substitute back into the original equation, which would be the absolute value. Now I'm going to substitute negative 2 in. So negative 2 minus 4. And then that absolute value is going to be increased by 2, and it should equal 8. So negative 2 minus 4 is negative 6. That absolute value plus 2 equals 8. The absolute value of negative 6 is 6. Increased by 2 does equal 8. I'm correct there as well. So my answer to the question, I'm going to change over to red. What values of x will work here? Well, x will work when x equals 10 or x equals negative 2. I'll accept either one of those. And when you're actually coming up with the answers, you have to put both solutions down. You can't just say, well, I got one of them. That's good enough, Mr. Alban, Ms. Fawn. That's fine. You must put both of them down because that is the solution to that particular absolute value equation. All right, so let's take a second or pause. And now we're going to do number 4. Number 4 looks exactly like the previous problem. It's set equal to positive 3, but there's a bunch of junk there. So I need to get rid of all that junk. And see what I'm going to do right now is I'm first going to subtract off 5 off of both sides. So I'll do that. So I've got my absolute value of 2x minus 1 all by itself. So far, so good. 3 minus 5 on the other side equals negative 2. Uh-oh. Wait a minute. Absolute values will never equal negative numbers. It's impossible. So at this point in time, if you try and continue to solve the problem, that tells me you really don't get the idea of absolute values. At this point, you should just stop and say, I'm done. There's no solution. If I do any more work right now, I really don't get the problem. You should stop right now and just say, no solution. You're not going to fool me on this one. It's impossible. And that would be your final answer here. Don't forget, those who have me, I've also taught you there's a Greek letter called phi that also means no solution. And so at that point, you can put that 0 with a slash through it. And that would also mean in mathematics quite often that it means no solution. So that's it through number 4. And I have one more problem that I'm going to go over with. The last problem I want to go over looks a little bit different because, wow, there's a 0 on the right-hand side. A 0. And I wonder how that affects anything. The fact that there's a 0 all by itself, let's see if that makes things a little bit strange. So if I do this, let's see, I have to get that absolute value stuff all by itself. So I'm going to divide both sides by negative 4. Okay. So I've got negative 3x minus 15. The absolute value of that quantity equals 0 divided by negative 4. That's 0. I still have a 0. Well, it's a little bit different here because, as you know, positive numbers, you could write a positive 5 with absolute value, negative 5 with absolute value. But when you have 0, there's no such thing as a positive 0 or a negative 0. 0 is just 0, has no sign. It's the dividing line between the positives and the negatives. So while when I break it apart, if I have it set equal to 0, I don't need to set it equal to two different equations. I can just go right ahead and write negative 3x minus 15, and I can set it equal to 0. Because it doesn't matter whether it's positive 0 or negative 0, which really doesn't exist. It's just 0. So at this point in time, I'm just going to solve, and I'll add 15 to both sides. And that gives me negative 3x has a value of positive 15. Divide both sides by negative 3. And I end up getting x has a value of negative 5. And when I come back up and actually substitute it back into the original equation, let's see what happens. So I put negative 4 times the absolute value of negative 3 times negative 5 minus 15, and that whole quantity supposedly equals 0. So when I simplify now, I get negative 4 times the absolute value of 15 minus 15 equals 0. Well, 15 minus 15, that's 0. So negative 4 times the absolute value of 0, which is really just negative 4 times 0, does indeed equal 0. That tells me that my answer is correct, so x equals negative 5 is the only solution that is going to work for this particular absolute value equation. So there's more to this than just what we've done so far, and actually on our next video that we're going to put together for tomorrow night, we're going to show you a little bit more about how to write equations. If you're given a word problem, how can you use that word problem to actually write an equation? And so that's what's going to come up on our very, very next video. As for now, though, that's about 12 minutes, and that's enough for today. Thank you, and have a great day, everyone.